All right, so keep in mind that we've been in a unit talking about systems. We're going to be looking at how to solve systems via elimination. We've looked at how to solve them using a graph and see where they intersect. We've looked at solving them by substitution, where you have two equations that you end up setting equal to each other and solving for x, and then plugging back into one of these to get your y. Remember that a solution is always a ordered pair, so you should always have an x value and a y value. You might have one or more, you might have none, or you might have infinite. But an ordered pair of x and y is always what we're looking for with a solution. All right, so let's look at tonight. We're going to look at elimination solutions. So how do we solve a system by eliminating? Well, we can do it by adding or subtracting, or we can do it by multiplication. Let's look at adding or subtracting first. All right, we're going to look at situations where I can solve this system in a non-traditional way. Remember that I could end up graphing. I could solve for y and I could plot, but both of these are in standard form. I really don't want to solve this by graphing. The other option I have so far is to find something where y equals y and solve both of these equations for y. But again, they're both in standard form and they both have big coefficients. I really don't want to do this because I don't want to work this problem for 15 minutes. So the next thing I can do is I can look at simply adding these two systems up and setting it up as an addition problem that I work vertically. So I'm going to rewrite my problem here. And notice if I think about adding this as a system, I'm going to add my 5x to my 3x, and I'm going to get 8x. I'm going to add my negative 6y to my positive 6y, and I'm going to get 0. Negative 6 and positive 6 cross out. That's convenient. And then I'm going to end up adding negative 32 to positive 48. What is the difference here? Hopefully you recognized it's 16. So now I end up with an equation that's super easy. 8x equals 16. Solve for x by dividing by 8. X equals 2. Remember, a solution is always an ordered pair, so I know my x value is 2. Well, knowing that x equals 2, I can plug this in for x in either one of these equations. It doesn't matter which one. Let's choose our top one. 5x minus 6y equals negative 32. Plug it in for x. X is 2. Okay, and what you end up with is 10 minus 6y equals negative 32. Okay, what do I need to do next? Well, just like before, I'm going to subtract my 10 from both sides. And I'm going to end up bringing down my sign. These cancel out, so I've got 0 minus 6y equals negative 42. Divide by negative 6, and I get y equals 8. I can plug this right in here. Now to check this, put it in either equation. Let's just take our top one because it's easy. 5x minus 6y equals negative 32. Let's plug 2 and 8 into this equation and see if that equals negative 32. If it does, our solution works out. So let's do 5 times 2 minus 6 times 8, and I get 10 minus 48. Uh-oh, I have an issue. I solved something wrong. Uh-oh, let's come back over here. Let's look at my x. Well, 16 divided by 8 is 2. That's correct. Well, look at this. Negative 42 divided by negative 6 is not 8. What is it? It's 7. All right. By checking, you can make sure that you don't make silly mistakes like this. So we're just going to double check one more time. We're going to take 5. We're going to plug our values in. 5 times 2 and 6 times 7. And I get 10 minus 42 equals negative 32. Yep, this ends up checking out. Whew, good job checking. Don't need a graphing calculator to check. I just simply need to plug them back into either one of these equations. On your own now, using this process, I would like you to solve, by using elimination, this system of equations right here. Solve and check your work. Show me both parts when you come into class tomorrow. All right, let's look at a real-life scenario in which this might end up really helpful for us. Let's say that I have a community center selling a total of 292 tickets for a basketball game. Student tickets are $1 and an adult ticket costs $3. The sponsors collect $470 in ticket sales. Write and solve a system to find the number of each type of ticket sold. All right, I want to find the number of each type of ticket. So that means there's more than one type. What two types do I have? Let's go back. I have student tickets that are $1, and then I have an adult ticket that costs $3. Okay, so I have a couple of things going on here. I know that my student tickets cost $1 each. And I know that my adult tickets cost $3 each. I know that I have 470 in total sales. So I have 470 equal to the amount sold of each. And I have 292 tickets that were sold total. So I need something to relate tickets. Well, I have two ticket variables. I've got my student tickets and my adult tickets. So 292 is the number of tickets. So it's my students plus my adults. And I have $470. So what do I know about dollars? Well, I know that my student tickets cost $1 each. And I know my adult tickets cost $3. And because it's a total, I'm going to add these up. And I have a system of equations that I can now use to tell me the total number of student tickets sold. I don't want the dollar amount of each, I want the number sold. So let's write that down and make sure we have this over here. And let's work on figuring out this problem. Okay, this doesn't look so bad. I could end up solving this by graphing. I could solve this by substitution, but a much faster way, and I like faster ways, is to solve this by elimination. Okay, if I have, let's think about this. Can I just simply add this? If I add these, am I going to get the same thing? What could I possibly do? Well, I can't multiply. That's not going to work. If I add these, I'm going to end up with something like 4a and 2s, and I'm going to get one really hunkin' huge number. That doesn't get me any closer to getting one variable that I can plug in and tell what the other means. So I'm going to do some multiplication first. This leads me into my next type of problem to do. Once I have a system like this, if I end up multiplying everything by the same number, then it stays balanced, right? All right. Let's look at multiplying this whole thing by -1. And if I do that, my equation changes. It becomes a negative a negative s, and a negative 292. At this point, I can add down, and I can get 3 minus 1 is 2a, and I get 0s, and I get that it equals, let's see here, 16 minus 9 is 7, 178. And at that point, to A equals 178. I can solve for A by dividing by 2. And my A equals 89. So what does that tell me? What does my A represent? Well, my A represents the number of adult tickets. So the number of adult tickets that were sold is 89. I still need to figure out the number of students sold. So I can come back up and plug 89 back into this equation. Let's choose 292 equals S plus A. This one's really easy. So I'm going to do 292 equals S plus 89. I can subtract 89 from both sides, and I'm going to end up with S equaling 203, which tells me that's the number of student tickets sold. Now, in order to check this, I want to plug both of these back into one of these equations. So again, I like 292 because it doesn't have coefficients. So 292 equals 203 plus 89. Is this true? Plug it into your calculators. Yes, it is. These numbers work. Now, just to play devil's advocate, what if I multiplied my top one by a negative number instead of multiplying my bottom? How would that change anything at all? Let's see. Let's go back in time and get rid of this -1. And let's look at multiplying my top here by -1. Remember to distribute it. So this is going to become negative, and this becomes negative, and this becomes negative. At that point, I get a -2a down here. I still get 0s, and I get -178. I can then divide by -2 on both sides, and my s still equals 89. All right, on your own now, I would like you to do this one. It's just like the other one. Your class sells a total of 64 tickets to a play. A student ticket costs $1 and an adult ticket costs $2.50. Your class collects $109 in total ticket sales. How many adult tickets did you sell? How many student tickets did you sell? Write your equations, set them up as a system, and see if you can figure out how to solve them using elimination. If you get stuck, take your information and go back and rewind this video to the word problem that I did and work it with me, using your own numbers and variables. All right, when you're ready, let's move on to a little bit more multiplication. We looked at how to eliminate systems by adding or subtracting and by multiplying by -1 and then adding or subtracting. Now I want to look at how you eliminate with multiplication. You've had a preview in our last couple word problems. Notice in the past we had systems that pretty clearly could be added and subtracted or made to equal 0. Again, I want to get one of these equal to 0. And usually these are standard form equations that aren't the easiest to manipulate into y equals mx plus b, or they would just take extra time. So to save us time on our test, we're going to end up doing this by the elimination method. We need to get either my x or my y to equal 0. All right, so if I look at this system, I don't have a clear way to subtract one or the other. I eventually want to get it into something that looks like this, where my b's end up canceling out. Or perhaps like this, where my a's end up canceling out. So sometimes in order for that to end up happening, I have to do a little bit of prep work first. So let's come up here and let's look at this system. If I have 2x plus 5y equals -22, and 10x plus 3y equals -22, I don't have a clear x or y that I can cancel. If I add these, I get 12. If I add these, I get 8. So I'm going to have to do something. Well, I could either, let's look at one easy solution. How could I get to either a 10 or a 3 from these numbers? Well, if I simply multiply this entire equation by 5 and distribute that out, I could get my x term to a 10. So let's do that. So 10x plus 25y equals negative 22 times 5. Let's make sure we figure out what that is. Right, it's negative 110. Okay, so now we're a little bit closer, but I still don't have any negatives. They're all positives. So at this point, I'm still going to end up with 20x or 28y, but I'm one step closer. Once I've multiplied by something to find a common coefficient, the next thing I need to do is multiply by a negative 1. The other way to think of this is simply putting my negative out in front of my bottom term and remembering to subtract the whole thing. Now personally, I prefer the way where I multiply the entire thing by negative 1, because at this point it helps me see that every term changes its sign. Let me show you. So you should get something that looks like this. If you simply keep your negative out in front up here, you run the risk of forgetting to change the sign for your negative 3 and your negative 22. So once you've multiplied by negative 1, now we can do our subtraction. So we're going to subtract this whole thing, every term. You're going to subtract your a's, so now I get 0x. I'm going to subtract my y's, so I'm going to get 22y. And I'm going to subtract over here, negative 88. Okay, so notice I did my first step up here. I multiplied to get a common coefficient. My common coefficient was 10, and then I multiplied one of my entire equations by negative 1. And the last thing that I did down here was to solve down. So I solved 10 minus 10 to get 0, 25 minus 3 to get 22, and I solved my c terms. So I'm left with this 22y equals negative 88. And now I need to divide by 22, and my y equals negative 4. Go back up here. What does it mean that y equals negative 4? Well, I was asked to solve a system of equations, and a system is solved by finding a coordinate pair. So my y value is negative 4. Well, what's my x? Well, let's just plug it into the first equation I've got up here. It's a pretty easy one to find x. So 2x plus 5 times y equals negative 22. Plug your y in, and you get 2x plus 20, negative 20 equals negative 22. Once I'm here, I now need to solve for x. So I'm going to end up adding 20 to both sides to get it away from the side with my x. 2x equals negative 2, x equals negative 1. So this is telling me that my ordered pair that solves this is 1 and negative 4. Okay, let's check that. Remember that to check, I'm going to take this ordered pair, and I'm going to end up plugging it into one of these equations. Now again, I kind of like multiplying by 2's and 5's, so let's just take the first one. So when I check, I'm going to take 2x plus 5y equals negative 22. 2 times 1 plus 5 times negative 4 equals negative 22. This is 2 plus negative 20. This does not equal negative 22. So this is telling me there's an error here. Fortunately, if I take just a look back over here for what I did with my x, I will notice that my x was negative 1 and I wrote it as a positive 1. Something just as simple as that can be caught just by checking your work. This would make it 2 times negative 1 plus 5 times negative 4, which would indeed equal negative 22. So make sure that you are always checking your work. It catches negative mistakes, it catches simple mathematical errors, and it's really not that hard to do. So what this is telling me is that this system of equations right here is comes to an intersection at the point of -1 and -4. Remember that when you have to solve by multiplying, you want to multiply one term by the other in order to get a common coefficient. Once you have your common coefficient, here it was 10, then I had to multiply one of my equations by -1 in order to get something that would cancel out my common coefficients. Now perhaps you're an out-of-the-box thinker and you don't want to do it that way. Or perhaps you are a person who just simply didn't see that 2 and 10 have something in common. Let's look at another way you could have solved this problem. Let's say I want to get my y's equal. What could I multiply both my y's to get the same coefficient in front of my y? Well, if I think about multiplying my top one by 3, 3 times 5 is 15, and then I could multiply my bottom equation by 5, that's going to turn this into a common coefficient of 15. Let's look at how this works. 6x plus 15y equals -66. How did I get that? I distributed my 3 to every single term. The next thing to do would be to distribute your 5 to every single term. So you get 50x plus 15y equals -110. Now I can move, I have common coefficients in my y's, and now I can multiply one of my equations by -1 and distribute. I personally prefer to multiply my bottom by -1 as it's just personal preference. You could do either one. Okay, so that's going to end up giving me something that looks like 6x plus 15y equals -66. -50x minus 15y equals +110. Now I can solve this down. -66 plus 110. At this point I solve it down. 6 minus 50 is -44. And 15 minus 15 is 0. And -66 plus 110 is +44. If I finish this all the way out, I divide by -44. And guess what? X equals -1, which, if you recall, this was supposed to be a negative that I miswrote on the previous problem. And that gives me the exact same answer that I got before. If I plug my -1 into one of my other equations, so let's do 2 times -1 plus 5y equals -22, you're going to discover that you get the exact same answer. Y is going to end up equaling -4. This is another way to do it. It doesn't really matter which one you multiply or which one's common, either your x or your y. Ultimately, it doesn't even matter if you multiply your top or your bottom by -1. It just needs to be only one of them. So that way you end up subtracting your fractions from each other. Solve for one variable, plug it into the next, and then solve for the other. So to rehash, multiply to get common coefficients. Multiply one equation by -1 to distribute. Solve it down. Solve for either x or y. And then plug that value into your other equation. And repeat step 3 and 4. The last thing you want to do is to check your work. Now, by check your work, it means to plug both points into one equation. Doesn't mean shove it in your calculator and see what happens. Plug both points into one equation, either your top or your bottom, and make sure that it equals the number it's supposed to. Then you're good. On your end, go ahead and solve this. Notice that because you have opposite signs in front of your x and your y's here, that you will not need to end up multiplying by -1. You just simply need to get your coefficients either for your x or your y to be the same. Go ahead and solve this. You should end up with a point 1 and -2. If you have any questions, we'll go over it tomorrow in class.